Integrated Math 1. Welcome to Module 1, Topic 1, Lesson 4. It's actually the last lesson in this topic. We're wrapping it up. So you've been introduced to several function families at this point. That last lesson in particular, oh my gosh. So you've been introduced to several function families: linear, exponential, quadratic, linear absolute value, and linear piecewise. So let's revisit the first lesson. A picture's worth 1,000 words. Remember, we had all those scenarios that we were matching up our graphs with. You remember way back in the very first lesson? So each of the scenarios in that lesson actually represents one of these function families. So first thing I want you to do is just take a moment, just describe how these scenarios represent functions, all right? So just take a moment to jot down your thoughts on that. Hit pause to jot it down, hit play to continue the discussion. So here's the deal. My thought was that each scenario represents a function because there is one unique output value for each input value. Remember, if I put something in, I only get one thing out of it. And each of those scenarios did that. And so, yes, they are functions, which brings me joy and happiness. Yay. Do you also recall that when we did these graphs, that these scenarios, you could either draw them with a continuous line or a continuous smooth curve? You remember that mess? When we did these were good times. So here's what you're going to do. Each of these scenarios, and if you want, you can go back to the first lesson and read through them again. I'm not going to, but you could. For each of these scenarios, I want you to tell me something about each one of these scenarios. And the directions are on page M163. The tables that you're going to put all your information, you're going to write down your answers in, are on the next couple pages. So just be aware of that. So we're going to fill in the table. So each table, in the first column, it's going to say what the scenario was. And in that first column, right underneath where it says what the scenario is, I want you to tell me identify the appropriate function family under the scenario name, and that's in the first column. For the second column, based on the context, I want you to identify the domain. Now, don't freak out that I'm asking for the domain. Actually, all I really want to know is whether it's continuous or discrete. You may need to go back and look those up. Continuous was I could put my pencil down and trace it and I wouldn't ever have to lift up my pencil. Discrete was a bunch of little points, a bunch of little dots. Remember that? So that's what I want in the second column as far as identifying the domain. I just want you to tell me whether my domain is continuous or discrete. The third column has the graphs, so you don't have to keep going back and looking at the graphs. You're okay. And in the fourth column, I want you to do that last piece for me, and I want you to describe the graphical behavior as increasing, decreasing, constant, or if it's more than one, tell me that. It's decreasing and increasing. Whatever it is, tell me what it is doing, all right? So go ahead and hit pause and go through your tables and fill them in, and then hit play when you're ready to check your work. Are you ready? So I'm coming to my first table. Yeah. First scenario was Daredevil, where he was cliff jumping into the water. A little crazy for my taste, but hey, to each his own. I noticed that my graph came in two pieces, that I had kind of like a curvy piece, and then I had like a straight piece. So I said it was piecewise because I literally noticed it came in two pieces. The curvy bit for when he was falling, and then the straight bit for once he hit the water. I do notice I can trace this with my pencil without ever picking it up. So I'm also going to say that my domain is continuous. And as far as my graphical behavior, well, he jumped off a cliff. So I'm going to go with decreasing. Usually when you jump off of cliffs, there's only decreasing. There's no increasing. I'm sorry. There just isn't. Something's fishy. That was where she had to clean the aquarium tank at the office, right? She had to take the fish out and drain out all the water. Looking at this graph, this is definitely just a straight line. Ooh, it's linear. That's right. This is a linear function. Also can trace it without picking up my pencil. That says it's continuous. And since she's draining the water, it is definitely decreasing. Smart mom, it isn't a smart deal. This is where your sketchy cousin was trying to loan you money, right? It kept doubling and doubling and doubling how much interest you were going to owe him. And that started to feel sketchy. So I'm going to say, especially looking at this curve and that whole double, 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 this bad boy is an exponential function. Definitely continuous. I can trace it without lifting my pencil, and definitely increasing, which means the only person that wins in that scenario is your cousin, okay? Be careful who you borrow money from. Oh my gosh. Can't wait to hit the slopes. That was where we were riding a really sketchy ski lift, which, again, some people are making very questionable life choices in these scenarios. That's all I'm saying here. But it kind of went up, and then the ski lift got stuck, and then went up again. And so I have like a bunch of pieces. And this time I noticed that my pieces are all lines. So I'm going to say this is a linear piecewise function. Again, I can trace it without lifting my pencil, so I'll say continuous. And while some of the pieces are increasing, that middle piece is constant. So I'm going to say it's increasing and constant. It's both. It's magic. And we are cutting pieces of rope in half, right? Cut it in half, cut it in half, cut it in half. And it's getting super small, super fast till we can't even cut the rope anymore. So I'm going to say that this is exponential. Now notice exponential can go up, but it can go down too. That is a thing. And I can trace it without lifting my pencil. That makes it continuous. And graphical behavior, it's decreasing. If I keep cutting things in half, they are definitely getting smaller. All right, baton twirling, where she chucks it in the air and she does her twirls and catches it. I used to try that, and I could toss it and I could twirl. I just didn't usually catch it, or it hit me on the head. That happened too. All right, so I made a better career choice than that. That's fine. It wasn't meant to be. But I am going to say, looking at how that baton goes up and comes down, that's a quadratic. It's got that U shape happening to it, most definitely. Again, continuous. I can trace it without lifting up my pencil. And I notice that it goes up and then comes down. So that means we were increasing and decreasing. That's a thing. Last two scenarios. Cold weather, right? This is where the number of people that showed up at the ski lodge kind of depended on what the temperature was. Again, I see three pieces, three lines, in fact. So I'm going to call this bad boy a linear piecewise function. It's definitely continuous. I can trace it without lifting my pencil. And I notice that it's also doing the increase, and then constant thing. So I'm going to say that it's increasing and constant. Last but not least, the jelly bean challenge, trying to guess how many jelly beans were in the jar. And I've never been very good at that, but it never stops me from trying. The jelly bean challenge, for a moment, I wanted to say linear piecewise because I noticed it had two pieces and that they were lines. And then I remembered the V shape, right? That V shape, that tells me that this is a linear absolute value function. It's continuous. I can trace it without lifting my pencil. And it does decrease. It does decrease and then increase. So I'm going to say decreasing and increasing on my graphical behavior. Think you're getting a better feel for this. I think we're kind of getting used to this. Now, let's go a little next level. So on this activity, we gave you scenarios and situations. We gave you graphs, and we said for you to describe the characteristics. But what if I switch that up on you? What if instead, in this next activity, I give you the characteristics, and you got to give me the equation and the graph? So in this activity, you will write equations and sketch a graph based on given characteristics. Now, don't panic. There's help here, okay? There's help. So using the given characteristics to create, use the given characteristics to create an equation and sketch a graph. And what you can do is use the equations in the box over here as a guide, all right? So linear function is f of x equals ax plus b. And just remember that a and b were just numbers, right? They're just numbers. So you can plug in any number you want for a, plug in any number you want for b, and then graph it. And that's all you got to do. Same thing with your exponential functions. Remember, it was f of x equals a times b to the x power plus c. And remember that a, b, and c were just numbers. So we could just plug in any numbers we want on those and graph it. Now, I'm going to warn you about a few things, though. First of all, since you are graphing these, if the numbers get too big, it's going to be really hard to graph them. So to help you, here's what I'm going to recommend. When creating your equation, use a, b, and c values that are any real numbers between -3 and 3. So you can use -3, you can use 3, you can use 0 or 2, you can use -1/2. You can use just pick numbers that are between negative from -3 to 3, just because it'll be so much easier for you to graph if you do. I promise. It'll just make life better. It really will. The other thing I'm going to ask is please do not use any functions that we used previously on this topic. So if we've used the function before, pick something different. Come on, guys. Be creative, be original, that kind of thing. This also means, though, that your graph may not look like your friend's graph, right? I mean, you may both come up with totally different equations, totally different graphs, but that still meet the characteristics. So there's no one right answer here. As long as it does all the things that it's being asked to do, then you should be good to go. So go ahead and work this out. There's 3, there's an A, there's a B, there's a C. So go ahead and do all 3 of these. You'll write the equation where it says equation. You'll put your graph on the graph right there. Just make sure that it meets up with all of the criteria. Go ahead and hit pause to work these out, and then hit play when you're ready to check your work. Are you ready? So again, your equations probably don't look like my equations, and that's okay. That's okay. You may have still done it right. It just may not look like my equation, and that's okay, which means your graph may not look like mine. As long as it does these things, we're fine with that. So for this first one, we want to create an equation and sketch a graph that is a function. Okay. It's exponential. Ooh, exponential. That means I got to use that whole f of x equals a times b to the x plus c. So I got to pick numbers for a, b, and c. I want it to be continuous. That should be fine. But here's the tricky thing. I want it to be decreasing. So the first time I did this problem, I picked a 3, a 2, and a -1 for my A, B, and C. But what I found was that when I put in a 2 for B, it made my exponential function increase. And this isn't supposed to decrease, so I had to redo it. And I realized that if I picked a half instead of 2, if I did 1 over 2, then it would happily decrease for me. So it's exponential. I used my exponential little guy. I used 3, 2, and a -1, except the 2 didn't work. So I used 1 over 2. 2 would have been fine if that had said increasing, but because it said decreasing, I did have to drop this guy. Also keep in mind that if you need to go back to those graphic organizers we made in the last lesson, that might help you out a little bit with your linear functions and your exponential functions. I'm just saying. The next one said linear, discrete, increasing, and a function. So linear means f of x equals ax plus b. Great, I'll pick a number for a, I'll pick a number for b. And so I picked 2 and -2. It sounded like a good idea. But the problem was this right here. It said it was discrete. And because it said it was discrete, I was like, okay, I don't want everything then. So I added on that little extra of saying where x is an integer. Because I noticed that when it said that, when we did our last lesson, when it said where x is an integer, that's where I got dots. So I got a discrete graph instead of a continuous one. Let's make sure it's increasing. Ooh, since my a is positive, it should increase just fine. And there it goes. Ooh, all the dots, so pretty. Again, you may have picked a different function, and that's okay. As long as it's increasing, it's linear, and it's a bunch of little dots, you should be all right. Last but not least, this one was tricky. This one was tricky, I'm not going to lie, because the first thing it said is that it wasn't a function. And I thought, but I had that moment, right? It did say it was continuous. It did say it was a straight line. And I thought, well, how can a straight line not be a function, right? Because if it was horizontal, it would only touch once. it was going up, it only touched much, going down, it only touched much. And then I remembered going back through our old graphs and old lessons, I remembered that vertical line wasn't a function. Did you remember that? Did you catch that? Did you go back and find that? It was tricky, but I got there. I found it. So I picked the equation x equals 1, which gives me a vertical line through 1. And then I was like, boom, not a function. Yeah. But it's still a straight line. It still does all the things I want it to do. Very convenient. So sorry about that. I had to throw one tricky one in there, okay? I had to throw in a little trick. I'm a math teacher after all. We are mildly evil. As always, I hope you found this helpful and I hope you found this useful. If you got questions or concerns, please email me or ask me during class or pop in for my office hours. That's what I'm there for. And I'll see you soon. Bye.